Hello, good evening. Am I audible?
Yes, sir.
Okay. Atif, do you have any doubt from last class?
No.
Okay. So we had just started how to calculate terminal velocity, or what do you mean by terminal velocity? We have to relate terminal velocity in terms of combination of drop. Suppose you have n number of drops, each having terminal velocity v1. If they combine to form single large drop, so how will this terminal velocity make it change? So we have to calculate that. According to formula, terminal velocity equals to 2 times of r square by 9 times eta bracket sigma minus rho times gravity. In this entire term, on going from one part to the other part, density of object will remain same, density of medium, gravity, and eta, these all quantity will remain same. Only there will be change in radius of these two bodies. So we have to somehow try to calculate relation between radius of these two bodies. So to find radius, just compare volume. Volume initial should be equals to volume final. We have n number of small drop, each having volume 4 by 3 pi r cube equals to 4 by 3 pi r cube. So 4 by 3 pi will cancel out. So you will left with r equals to n to the power 1 by 3 times small r. So from this, we can say velocity is proportional to r square. So v1 divided by v2 equals to r1 divided by r2 whole square. Now put the value of each term. R1 is just r and r2 is n to the power 1 by 3 times small r whole to the power 2. R and r will cancel out. So you're left with 1 upon n to the power 1 by 3 and whole to the power 2. So it will be v1 divided by v2 1 upon n to the power 2 by 3. Just cross multiplication it. So you will get v2 equals to n to the power 2 by 3 times v1. So this will be a required expression for velocity of single drop on combining small part. Yusuf, is it clear?
Yes, sir.
Irfan, any doubt?
No, sir.
Okay, just write it down. You all have written? Atif, done? Now let me give you a question related to this part. If raindrops are falling at 4 mm per second, if 8 drops combine to form single drop, find its terminal velocity. Just use the above expression. In this question, we have velocity of each initial drop as 4 mm per second. So it will be V1. Number of drop is 8. Just find V2. Riba, got any answer? Atif, just check your calculation. According to the formula, V2 equals to n to the power 2 by 3 times V1. Let me solve this particular fraction. N is 8, having exponential 2 by 3. So we can write 8 in terms of 2 as 2 raised to 3 and whole to the power 2 by 3. So power to the power will get multiplied. So it will be 2 to the power 3 multiplied by 2 by 3. So this 3 and this 3 will cancel out. So you're left with 2 raised to 2, which is nothing but 4. So now put this. So it will be 4 into V1, that is 4. So it will be 16 mm per second. Atif, is it clear? Good, Riba. Yusuf, any doubt?
No, sir.
Okay. You all have written?
Yes, sir.
Okay. Next is equation of continuity. Suppose you have a tube of varying cross section. Area of cross section at this end is A1 and at this end is A2, in which liquid is flowing and which should be non-viscous and incompressible. So that layer of or each layer of liquid will move with same velocity at this given cross section, let's say V1, and at this instant, velocity of each layer will be V2. So we have to calculate relation between area and velocity corresponding to any given condition or any given position. So consider a non-viscous incompressible liquid is flowing in varying cross-sectional area of tube So we have to calculate area and velocity or relation between them. So let's say it's at first part, mass of liquid entering per unit time equals to mass equals to density into volume. So we can write density into volume divided by time. Volume is area of cross section times length divided by time t. This length per unit time may be also written as velocity. So we can write it as rho a v1. Abhinav, is it clear?
Yes, sir.
So this is mass of liquid entering at this first crossing area per unit time. So similarly, we can write mass of liquid ejecting per unit time. So it will be rho, as density is constant, so it will remain rho. Area of cross section times velocity. Let's say this is equation first and this is equation second. Now, according to conservation of mass, we can say mass of liquid entering in this particular tube from one end must equals to mass of liquid leaving or ejecting from the other end, so that mass remains conserved. So we can write, according to conservation of mass, according to conservation of mass, mass of liquid entering per unit time will equals to mass of liquid ejecting per unit time. Now put the expression what we have derived above in these two parts. So you'll get rho A1 V1 equals to rho A2 V2. Rho is same on either side, so just get cancel out. So you're left with A1 V1 equals to A2 V2. Atif, is it clear?
Yes, sir.
Yusuf, any doubt?
No, sir.
Okay, just write it down. You all have written?
Yes, sir,
One
written,
minute,
sir.
sir.
Rehab, any doubt? Ishan, you're done? Okay. Now, this particular product, area and velocity, is also termed as rate of flow of liquid. So it will be represented by Q equals to area times velocity. So this product will be constant for the flow of non-viscous incompressible liquid in a tube. Now, let me define you a question related to this. Suppose you have a tube this having area A, this having area 2A, in which liquid is flowing at 5 meter per second, and this part at 4 meter per second. At the other end, suppose we have some small hole. Number of hole is 10, each having area A by 20. So find velocity of ejection of liquid. Let me define you how to approach this problem. We have two different tubes through which liquid is entering into it. So you can say total mass of liquid entering per unit time from these two ends should be equals to total mass of liquid ejecting out from these small holes. So according to principle of or equation of continuity, A1 V1 plus A2 V2, since these two tubes having same direction of flow, which must be equals to n number of hole, each having area A3V3. Now put the value of each term and simplify it to find V3. Atif, is it clear?
Then can you please explain it again?
Yes.
Okay. We have first in left side two different arms, one this and the other this, in which liquid is flowing towards the right side. And this arm, we have liquid in towards right side. So you can say both these two arms in which liquid is flowing along same direction. So we can say total amount of liquid entering into this tube will be sum of these two terms. Is it clear?
Yes, sir.
And there is only one section through which liquid will comes out, that is the right side part. So according to it, we can say total mass of liquid entering, that will be A1 V1 plus A2 V2 should be equals to n number of small holes A3 V3. So put the value of each term and simplify it to find V3. Good, Abhinav.
It's correct.
Yeah. Good, Atif. Let's say A1 is A, velocity of liquid in this section is 5. A2 is 2A, velocity of liquid in this section is 4. We have 10 number of holes, each having area A by 20 and velocity V3. So this 0 and this 0 will cancel out. 5A plus 8A will be 13A equals to A by 2 times V3. A and A will cancel out. So you'll get V3 equals to 26 meter per second. Mohammad Irfan, is it clear? Yusuf?
Yes, sir. It is clear. It is clear.
Yes, sir.
Okay. You all have written?
Yes, sir.
Okay. Now there will be a conceptual question related to this equation of continuity. Suppose you have a
Hold up 1 second. Thank you, sir.
suppose you have a tap through which liquid is coming out. So the shape of liquid stream ejecting out from this tap may follow this type of structure. Initially, it having wider stream, but on going down, width of stream gets shrink. So question is, why width of stream is decreasing continuously on falling down? Why width of stream decreases on falling down? Abhinav, any idea?
No, sir.
You have experienced this or not?
Yes, sir.
Okay. Atif, any idea? Muhammad Irfan? Would you like to answer?
Sir, is it because the flow of the water stops?
At what point? It continuously flowing. Suppose tap is at some height from which liquid is coming out and falling down. So on falling down, its width decreases continuously. Why it so happens? Riba? Let me give you a concept. Just say, or take this particular point as a reference. So I'm moving to this point or moving to this point. As it fall down, height of or distance covered by this liquid will increases. So according to the concept of free fall, velocity equals to root under 2gh. So on falling down, h increases, so velocity increases. And then according to equation of continuity, a1 v1 should be equals to a2 v2. So as velocity increases, so width must decreases, so area will decrease. Is it clear?
Yes, sir.
So
Yes,
you'll
sir.
say on falling down, distance or height of falling increases. So velocity increases, hence area decreases due to the concept of equation of continuity. Just write it down. You all have written?
Yes, sir.
Yusuf,
1 minute, sir. Done, sir.
okay. So this is all about equation of continuity. Next, the most important part of this particular chapter is Bernoullis principle. Suppose you have a tube of varying cross section and whose end is at different level. A tube having varying cross section area A1 at this point. So velocity of liquid at this instant is V1. At this point, area is A2, so velocity is V2. Next, height of this point from ground is H1, and height of this point from ground is H2. So if you have to move liquid in this particular tube from lower end to some higher end, so you must need some external agency to do some work to move this liquid from this lower end to some other end. So to compensate this or to do this particular function, pressure is applied at this end, let's say P1, and at this end, P2. Due to this pressure difference, it will be capable of traveling of liquid from one end to the other end. So according to Bernoullis principle, say if liquid is non-viscous, incompressible, flowing in a tube, so at any instant, sum of pressure, kinetic energy per unit volume, and potential energy per unit volume will always be constant. So let me define you. If non-viscous, incompressible, liquid is flowing in a tube, having variable cross section, then sum of pressure, kinetic energy per unit volume, and potential energy per unit volume at any instant will be constant or conserved. Abhinav, any doubt?
No doubt, sir.
So we have to prove this particular statement and we have to define sum of pressure, kinetic energy per unit volume and potential energy per unit volume is constant. First, write it down to this part. You all have written?
Yes, sir.
Okay. So to prove this particular statement, there is some limiting condition. First is non-viscous, second is incompressible. So limitation of this particular Bernoullis principle is non-viscous liquid. It should be incompressible. Third, gravity should be constant, or there will be no impact of gravity due to changing height. And third, fourth, energy should be conserved. Now, due to this pressure difference, there would be some work done on this particular fluid. So let's say work done due to pressure difference. Since work done is nothing but force times displacement, we can write force in terms of pressure as net pressure into area of cross-section times displacement. Area times length will be nothing but volume. So we can write pressure net or net pressure as P1 minus P2, area times length as volume. So this would be total amount of work done by pressure difference on this particular liquid. Abhinav, is it clear?
Yes, sir.
Now, according to work energy theorem, the amount of work done must equals to sum of change in kinetic energy and change in potential energy. So we can write, according to work energy theorem, work done equals to change in kinetic energy, change in potential energy. Now put the value of each term. Work done is P1 minus P2 times volume. Change in kinetic energy is half mv square minus half m v1 square. Potential energy is mgh, so it will be h2 minus h1. Atif, is it clear till this part?
Sir, can you explain again?
Since you have to move this liquid from lower end of tube to some upper end, so there should be some external agency to cause this particular flow. So here we have external pressure difference at these two ends, which will be capable of doing some work to move this liquid from lower end to other end. So I've just defined work done due to pressure difference. As work done is nothing but force times displacement, we can write force equals to net pressure into area of cross section. Area times length is volume. Net pressure difference is P1 minus P2. So the total amount of work is equals to P1 minus P2 times volume. Is it clear?
Yes, sir, it's clear.
Now, according to work energy theorem, I simply state if work is done on a particular system by any external agency or any non-conservative force, this will result in change of kinetic energy plus potential energy. So work done equals to sum of change in kinetic energy and potential energy. Then I have put the value of each term respectively. Now move this volume to right side. So you'll get P1 minus P2 equals to half mass divided by volume, V2 square minus V1 square plus mass divided by volume times gravity, H2 minus H1. Next, mass divided by volume is nothing but density. So this will become density. Similarly, this will become density. So it will be half rho V2 square minus half rho V1 square plus rho G H2 minus rho G H1 equals to P1 minus P2. Mohammad Irfan, is it clear?
Yes, sir.
Okay. Now just rearrange this equation to keep the same subscript to one side and rest to the other side. So we can write this expression as P1 plus half rho V1 square plus rho GH1 equals to P2 plus half rho V2 square plus rho GH2. Now we have same quantity on either side and there is only change in their subscript. Therefore, we can write P plus half rho V square plus rho GH at any instant for the flow of non-viscous incompressible liquid is constant. Abhinav, is it clear?
Yes, sir. Clear, sir.
Rehab, any doubt?
No, sir.
So this is pressure, this is kinetic energy per unit volume, and this is potential energy per unit volume. Sum of all these three terms at any instant for the flow of liquid should be constant. Just write it down from this part. You all have written?
Yes, sir.
Rishan? Yusuf?
Yes, sir.
Okay. This is the most important derivation of this particular chapter. So do some practice to revise this. Now, there is some various application of this Bernoullis principle. We may write this expression in some other form as well. Since in this particular expression, density of liquid and gravity will be constant. So if you divide this entire part by rho and g, you will get P divided by rho g plus rho b squared by 2 times of rho g plus rho g h divided by rho times g, and constant by rho g will remain constant. Rho times g will cancel out. So you're left with P divided by rho g plus velocity square divided by 2 times g plus h equals to constant. Now this expression, pressure divided by rho times g, is called pressure head. Velocity divided by 2 times of gravity is called velocity head. And this height is called gravity head. So you can say some of these terms at any instant for the flow of liquid should be constant. Or you'll be asked directly to find velocity head at a particular instant of motion. Is it clear? Abhinav, any doubt?
No doubt, sir.
Okay. Yusuf, done?
Last part, sir.
Muhammad Irfan, any doubt?
No, sir.
Done, sir.
there is one announcement. In next class, I will take your Viva. Okay. So for that, just prepare hydrodynamics only, from Newton's law of viscosity till Bernoullis principle. Okay.
Yes, sir.
Now, application of this particular Bernoullis principle. First application is Magnus effect. Suppose, just wait, Umar. You have a ball. If it is thrown without spinning, so it may follow this path to hit the ground at some distance, this point. So this particular trajectory is due to without spinning. Now, suppose if it is thrown with clockwise spinning, will there be any change in trajectory of its path, or it will remain same? Atif,
Sorry, sir, can you repeat?
will there be any change in trajectory while spinning?
No, sir, I don't think so.
Okay. Let me define you. Suppose this ball is in clockwise direction. So the air around it must be moving opposite to it. Similarly, at this point, velocity of air will be along this direction. Now, at this topmost point, since velocity of both these two terms is in different direction or opposite direction, velocity of air is in backward direction and velocity of spinning of ball is in forward direction. So these two velocity will get subtracted. So velocity will get decreased. And at bottom point, since the direction of these two motion is along same direction, so they will add up. So velocity will increase. Abhinav, is it clear? Atif, any doubt? Now, according to the rule, or according to Bernoullis principle, P plus half rho V square rho GH is equals to constant. In this expression, Hs or rho GH is due to potential energy. So height of this ball is constant. So just neglect it. Next is pressure and velocity. So if velocity is decreasing, pressure must increase so that sum of these three terms at this instant will be constant. Similarly, at bottom part, if velocity is increasing, pressure must decrease so that sum of these quantity at this instant should be constant. Muhammad Irfan, is it clear? Atif, is it clear?
Yes.
Now just say, in which direction pressure is more? Upper side or lower side? we have larger pressure towards upper side and smaller pressure towards lower side. So according to the rule, matter flows from higher pressure to lower pressure. So we can say pressure at higher level is greater as compared to lower point. So due to this pressure difference, this ball will deflect toward downward, so it may hit at this instant. Is it clear?
Yes.
sir.
So this particular path or trajectory of this particular ball will be due to clockwise spinning. Similarly, if this ball will move in anti-clockwise spinning, so it may hit or follow this trajectory. And this middle part, no spinning. So this effect is basically based on Bernoullis principle. It is also called Magnus effect. Yusuf, any doubt?
No, sir.
Okay, just write it down. From this, you'll be asked to define only clockwise spinning and anti-clockwise spinning. That's it. You all have written?
One minute, sir. Done, sir.
Yusuf, done?
Yes, sir. Done.
Okay. There will be another interesting question. Suppose you have a paper. Just unfold it inward to form like this. Is it visible?
Yes, sir.
So you'll be asked to blow air over it. So in which direction this spiral will move? Whether it will move upward or downward.
So downward.
Sir, upward.
Just perform this experiment. Take a piece of paper and unfold it in downward direction like this and blow air over it. Like this. This is based on Bernoullis principle. Let me define you its mechanism. Suppose you have paper which is in fold inward like this. So if you blow air over it along this direction, velocity increases, pressure decreases. So due to this decrease in pressure at this upper level, this enfold paper will tend to go up. So it may get straightened. Is it clear?
Yes, sir.
Atif, any doubt?
No, sir, no doubts.
Okay. On the basis of this concept, we can define takeoff of aeroplane. Suppose there's aeroplane first it runs on a runway. So due to running, air from front side may move along this way from its top surface, but from bottom end, on hitting its surface, it may get stopped. Due to this, velocity at bottom end will get decreased and velocity at this upper end will get increased. This change in velocity will lead to change or pressure difference. So at this point, pressure will get decreased, and at this point, pressure will get increased. And this pressure difference will be enough to uphold this particular whole plane. Is it clear?
Yes, sir.
Yes, sir.
Let me define you the mathematical relation behind it. According to Bernoullis Principle, we can write P1 plus half rho V1 square plus rho GH1 equals to P2 plus half rho V2 square plus rho GH2. As there is no any significant change in height, so these two terms will almost equal. So they will cancel out. So move this P1 to left side. So it will be P1 minus P2, and move this term to right side. So it will be half V2 square minus V1 square. This pressure difference will be capable of uplifting this entire plane. So pressure equals to force by area. So force is due to mass times gravity divided by area of its surface equals to rho by 2. We can write this particular expression as a square minus b square. So it will be a plus b times a minus b. So it will be a plus b times a minus b. Next is this particular term, v1 plus v2 divided by 2 will be nothing but average velocity, and this particular term will be nothing but change in velocity. So we can write density times average velocity times difference in velocity equals to this much amount. So difference in velocity between upper and lower end will be equals to mg divided by rho a times average velocity. So this is an expression how much there will be difference in velocity between two different ends. So there is a question on this particular expression. Atif, Is it clear? Mohammad Irfan, any doubt?
No, sir.
Rehab? Okay, just write it down. Yusuf, done? Rishan, any doubt?
Done, sir.
Okay. A plane carrying total mass of 2 into 10 to the power 4 kg having area 25 meters square is moving at 900 kilometers per hour. Find difference in velocity between upper and lower end. Density of air is 1.3 into 10 to the power 0 kg per meter cube. Take gravity to be 10. Just put all the values in the above formula and simplify it.
Sir, is that 90 kilometer per hour?
900 kilometer per hour.
Okay, sir.
You have given mass as 2 × 10⁻³ kg, area as 25 meters square, velocity as 900 kilometer per hour. So just multiply it by 5/18 to convert it meter per second. And density is 1.3 kg per meter cube. Just put all the values in the above formula and simplify it. Mass is 2 × 10⁻³, gravity is 10, divide by density 1.3, area 25, velocity 18 5s. So it will be 250. This 0 and this 0 will cancel out. You can write 25 and 4 times 5 8s and 5 5s. So 8 into 2, 16, divided by 5 is 3.2, divided by 1.3. So it will be around 13 2s, 26, 6 0, 13 4s, and about this much. Adif, you have done a mistake. Is it clear to all of you? Mohammed Irfan, any doubt?
No, sir.
Rishan? You all have written?
Yes, sir.
Next, the last part of this particular topic is Torres-Tree law. Which is based on Bernoullis principle as well. Suppose you have a tank and there is a hole in it at this point. Suppose liquid is filled in this particular tank up to this level. And due to this hole, there will be liquid coming out like this. So Torres-Tree law basically defines you how to calculate or how the velocity of liquid or velocity of ejecting liquid will behave. So just assume this particular tank as one opening of tube and that's this end, and the other end is at this point. Is it clear? Let's say this is first end and this is second end. Now, position of each term, total height up to which liquid is filled is capital H, and there is hole at H below, so it will be H minus H. Since at this point there is opening or direct exposed to air, so there will be pressure due to air that is called atmospheric pressure, and at this point also there will be pressure due to atmosphere that is P0. Since this particular area is very large and this hole is very small. So the level of liquid or decreasing level of liquid at this particular level will be very small, that we can take this particular term to be almost zero. And velocity of liquid ejecting out at this point is VE. Do you have any doubt till this point? What I have assumed? Atif?
Yes.
Consider a large open tank in which liquid is filled up to H, and a hole is made at H below the level of liquid. Now, according to Bernoullis principle, pressure plus half rho V1 square plus rho G H1 equals to pressure plus half rho V2 square plus rho G H2 should be equal to each other. Now, if you put all the values related to this term, P1 will be atmospheric pressure since it is directly exposed to air. V1 is almost zero, so it will be zero. Rho G H1 is capital H. P2 is also atmospheric pressure. Half rho V2 is velocity of liquid ejecting out from this hole, which is VE. And rho G H2, that is height of this hole, H minus H. So this P naught will cancel out. Move this term to left side, so you'll get rho GH minus rho G capital H minus rho G small h equals to half rho V square. This term and this term will cancel out. Rho and rho will cancel out. So you'll get velocity PE equals to root under 2GH. This velocity is called velocity of efflux or velocity of liquid ejecting out from this hole. Is it clear?
Yes.
Now, do you think you'll think what is special about it? Just see this particular expression. Velocity is under root 2GH. Suppose you have a body which is at this height whose initial velocity is 0. So on falling down by some height h, according to third equation, we can write v square equals to u square plus 2gh. Since u is 0, so it will be 0. So velocity will be equals to root under 2gh. Is this two expression are equal? Irfan? Are these two expressions equal to each other or not?
Yes, sir.
So we can conclude,
Yes, sir.
as a body falls freely under the effect of gravity, similarly liquid does. Is it clear?
Yes, sir.
Okay, just write it down. You all have written?
No, sir, writing. Done, sir.
Okay. Now just see this particular geometrical parameter, this particular path only. It is behaving just like projectile motion or horizontal projectile, in which a pod is projected horizontally with some velocity v from some height h minus h. So we can calculate time of flight range related to this part. So time taken by liquid to hit the ground. According to second equation of motion, S is equals to ut plus half times at squared. There is no any vertical component of velocity initially, so it will be 0. S is h minus h. Half acceleration is due to gravity g, and time taken is t squared. So on solving, you will get t equals to 2 times h minus h divided by gravity, root under. Now, related to this time, we can find horizontal range as well. Horizontal range. So according to horizontal motion, we can write S is equals to ut plus half at squared again, but in this part, we are considering only horizontal motion. So total horizontal distance will be r. There is some horizontal velocity as ve, time taken is t, and there is no any acceleration horizontal direction, so it will be 0. Now put the value of v, so you will get 2 times root under h minus h only. So this will be your range of that particular falling. Now you'll be asked to find condition for maximum range. I defined you in mathematical physics. If you have to calculate maximum or minimum value of a particular function, just differentiate that part and put it to 0. So similarly, in this, we have to calculate maximum range. So just differentiate this range with respect to h and put it to 0. You will get h is equals to h by 2. It means if a hole is made at the midpoint of tank, you will get maximum horizontal range. Is it clear? So related to this, range will be R max equals to H. So you'll be asked directly if a tank is of 4-meter height or 2-meter height. So at which point a hole is made to have maximum range. So just remember this particular relation. It should be at midpoint of it. Atif, any doubt?
No, sir.
Riba?
No, sir.
Okay. In M part, I have taken vertical motion, and in below part, I have taken horizontal motion. You all have written?
Yes, sir.
So do you have any doubt till this part?
No, sir.
Okay. So this is all about this entire chapter of fluid. We have just completed it. So let's stop here for today. In next class, we'll start with new chapter, that is thermal properties of matter. The next most important part, just revise hydrodynamics part only for the Viva. Okay.
Okay, sir.
Okay then. Take care. Good night.
Take care, sir. Good night.
Thank you, sir.
Thank you.